Good day, I'm Dr. Ting. In this module 2.2, we're going to explore Internet of Things. As we have looked at Internet of Everything, Internet of Things is actually a part or a subset of Internet of Everything. What is Internet of Things? It's basically connecting any devices and then share the data to anybody in any way, and it is applicable to any businesses in any network at any time. Now, when we talk about time, any place, and anytime communication, including no matter on the move or at night or daytime, at any place communication, including outdoor, indoor, which is away from computer or at the computer. Whereas anything communication, which will be between the computers, human to human, not using a computer, human to thing, using generic equipment or thing to thing. Now, in terms of features of Internet of Things, it is intelligence, which means that it will be collecting the data based on the sensor or based on the actuator that you have set. Say, for example, if you have set that when the temperature drops for certain degrees Celsius, then it will collect the data. And it is connected to the network, to the internet, and it is also connected with the devices or connected with each other. The features of Internet of Things as well is in terms of the dynamic nature in which you will be able to preset the timer that you want them to react accordingly. And it is at enormous scale, which also means that you can preset or you can install a large amount of the sensor or actuator in your industry or at the plantation in order to accurately collect sensitive data or very accurate, precise data at a time. Then this kind of device is actually sensing the environment changes and collect the data accordingly. And lastly, feature of IoT is heterogeneity, which also means that you can combine different kinds of devices. They are not same kind of devices. For example, you can connect your handphone with your laptop and then with your home devices, with the wearable devices, and etc. So this kind of devices are heterogeneity. They are not the same kind of devices. Why IoT now? It's because of the ubiquitous connectivity that we have nowadays and also widespread adoption of IP that we are connected to the internet, and we have even more than one IP at our home or in the office that we're using, and also the rise of cloud computing, which we store everything in the cloud storage, like for example Google Share Drive. Advances in the data analytics, not only in the traditional data analytics, but also in the big data analytics, and miniaturization of the devices, which is available in a low cost. The importance of getting things connected. Say, for example, we have different kinds of use cases. After this, we will be looking into different industry, why we need the Internet of Things in different industry. Say, for example, I need to maintain the quality of my goods. Am I healthy? So this is from the health industry. When is the next bus? This is from a consumer in the transportation needs. Where can I park my car in a shopping mall, and etc. And from this diagram as well, from connecting devices to human value, first you get connected, device connection and connectivity. So you connected all the devices together and sensing and collect the data. Then you are going to transport and pass the data back to the to the server in order to analyze your data to become important or informative data, or we call it as information. And then this will actually define the value of your data by actually giving you support in your decision making, and you take action based on it. And this will be bringing you different human value through this smart application. There are several phases of IoT maturity phases as well, from monitoring, simply just monitor and collect the data from the environment, to monitor, like say for example in your smart home, you just want to monitor what is the temperature now, or whether there is any intruder to your home, to control. When you come to the control means you are going to, let's say for example, adjust temperature in your home, or where there is a intruder coming in, you want to control the lightning, you want to switch on the lights immediately to scare off the intruder. Then to the next phase, which is optimization, the process, say for example, within 1 second time after the intruder break into your house, then you set and optimize it that at the same time, you're going to report to the police, you're going to send email or message to your neighborhood to inform them that come quickly to your house. And the last phase will be autonomous, in which it will take action by itself. IoT devices, networks, and system. What are the components of IoT system and how they are connected to each other? Let's take a look at this diagram. Basically, we have different kinds of devices or sensor or actuator that is embedded in your devices, and they are going to collect things, and your devices as well, such as the mobile phone, iPad, or a computer, are actually collecting data as well, and they are going to collect the data, all these devices, and send through the internet to the server, and the centralized server will be processing your data and going to provide you some information, valuable information, in order to be used in data management, data repository, in a communication interface, in a web application. 4 stages of IoT solution architecture. Now again, this is actually based on one of the paper by the researchers, which is in their solution in a very specific case study. So this is just an example to bring out that the whole architecture will be complicated, and then they are going to have this so-called IoT ecosystem, which includes the integration of your device with the software, and all the components need to be made available to be used together as a system together. So they must be connected together in order to achieve this IoT solution architecture. Some market potential examples. Let's go through some use cases in different industry. For example, construction. You can reduce the rental cost, send underused equipment where it is needed, show alerts and order replacement before equipment breaks down. Because when you use the equipment, you have sensor to sense the equipment, like for example, the age, how the performance it is. So when the performance is degrading, you know that the equipment is going to break down soon. So based on this data collected from your sensor, you can actually place order for new equipment replacement. Track all assets, never lost expensive equipment again. Extend the lifetime of your asset with informed decision. In another industry, say for example, transportation. Now, connected cars are a top IoT device according to this article. And let's take a look at this revenue. In 2022, it's about 80 billion dollar of the revenue in 2022 for vehicle management, mobility management, entertainment, driver assistance, safety, and other applications in the market in terms of transportation. In terms of insurance industry, a survey has found that 74% of insurance executives believe that IoT will disrupt insurance within the next 5 years. 74% also plan to invest in developing and implementing IoT strategies by 2016. Let's take a look at 9 settings that give us a cross-section sector view of total potential impact of 3.9 trillion to 11.1 trillion per year in 2025. The IoT and the insurance industry. In terms of the home, we have 200 to 350 billion. That's quite a lot. In terms of office, security, energy, factories, different kinds of insurance, retail environments, work sites, human, outside cities, public health and transportation, vehicle, homes. So the Internet of Things will create trillions in economic value throughout the global economy by 2025. What are the opportunities, challenges will create for insurers? What are the impact on the insurance industry value change? For connected homes, this is one of the most popular application, and we are getting use of it nowadays. Say for example, smart meters are already in reality from 313 million installed in homes worldwide in 2013. It is going to jump to 1.1 billion by 2022 according to this article. And these are some example of the smart home that you can apply or implement. Smart home appliances, so smart lighting, smart thermostats, the healthcare and assisted living system, smart speakers, security and access control system, and others. In terms of healthcare, the market size for IoT in healthcare industry will grow from 30% rate, growing rate of 30%, and will reach 267 billion in 2023. This is one of the statistics here. And let's take a look at this diagram. This is the global IoT in healthcare market. 2013, North America has the largest market by region. And 2017, market size 56.1 billion. And this is a growing rate. And for APAC, APEC countries, fastest growing market by region 2018 to 2023. And if you are interested to look at the detailed statistic, you can visit this link. In terms of smart building, 43% of building managers in US believe that IoT will affect how they run their building within the next 2 to 3 years. This is according to one of the survey done by this guy. And the smart building means that you are connecting several kinds of devices, sensors, which include the lighting, the power supply, the disaster, the fire alarm, and so on and so forth, including the security and the processes of your building, services, connecting to it through the internet. The users will be able to sense this and collect data from here, get informed regarding any disaster that's happening or what are the services available. Like for example, car park system, you'll be able to sense whether there is a car park here and there. And then on the desktop control, you'll be able to get the data and also control from your desktop. And this definitely will need the cloud server. We're looking at the cloud. We will look and discuss about this cloud server in another module. Now, in manufacturing nowadays, we are moving from Industry 1.0, 2.0 to 3.0 and 4.0. And Industry 4.0 basically means that you have this everything, Internet of Things, cyber physical system, Internet of Things, the network, everything connected together. Industry 3.0 is about automation, computer, and electronics, but not yet connected. Not everything connected together. And then we have earlier version, Industry 3.0, which is focusing on mass production, assembly lines, electrical energy in 1870s and even the earliest. In terms of agriculture, so this is also popular application everywhere, especially in China. They make use of IoT to transform their agriculture sector. Say, for example, in the crop yield analysis, in the auto spreading of their watering system, diagnosis of the disease, and then variable rate of fertility, water stress, field monitoring, soil erosion, smart data, and etc. And everything is available in an iPad that you can monitor, and you can even automate certain processes. What kind of data that you are going to collect from the Internet of Things devices? It can be sensors that you embedded in pet collars, internet browsing data, moving around with your smartphone, and also sensor in ocean, in whatever devices. So the data that you have collected will eventually become a big pool of data, which we call it as big data. There are 4 V's in big data, or the characteristic of big data. The first is the volume, the scale of the data that's very, very big as compared to the traditional data that you have collected, can go up to zettabytes. And in terms of the second V of big data will be the velocity. It will be the speed that you collect the data, it is per second. It is counted as per second instead of per day or per month. So every second it is increasingly very crazily. The velocity means how fast you get the data. In terms of veracity of the big data, this from meaning that you are going to collect from different forms of data sources. From YouTube, it can be structured data type, unstructured or semi-structured data type, and different kinds of from different kinds of devices. And lastly, the other V will be veracity, which is the uncertainty of data. You might be collecting a lot of data, but remember that the raw data itself brings no meaning, because it might be just 1 and 0, it might be just numbers, it might be just characters. So the uncertainty value of the data or the stability of the data is unknown in big data. How about the data ownership? Who owns the data? Is it the one that set up the web camera or the CCTV camera? Is that the company that owns the CCTV? Or is that the city government, the state government? So who actually owns this data? Now, there is one researcher, a group of researchers that proposed this data ownership conceptual model, which tells us that in order to identify the data ownership, we will need to identify the data possession, the right, who has the right over the data, and who has the control over the data, and granting the rights to who has the right to grant this right, and who has the right to get this right of the ownership, and who has the responsibility for the data, the management of the data. And based upon the foundation, the data ownership will based upon the foundation of legal aspect, which also means that you must fulfill legality of your data. When you collect the data, it must be legal, it must be ethical, and the type of data must be identified, what type of data that you are going to collect, and you have to identify the technical requirements and also the case requirements, what you are going to use this data for. So based upon this foundation, you are going to further identify who is going to own the data, manage the data, and manipulate the data or share the data. Value is created by making sense of data. So this is the pyramid of the data of value. When you have data, and you have basically bring no value, because they only brings symbols like 1 and 0 or characters. But when you process, after you have processed the data, it will become a set of information. Then this set of information might be able to answer who, where, what, when question. Then further up, when you transform the information into the knowledge, you might be able to answer the question of how could this happen. It's just like your data analytics. You might be in your descriptive analytic, you just present the graph, the statistic of the sales of the year, but you don't know how this is happening or how these sales actually shoot up so fast. What is happening is answered under the information, but how do you deal with it? How do you ensure that your sales will be able to increase next year? And appreciation of why this is happening as well. When you further go up, further analyze your data in detail. And lastly, wisdom, evaluate the understanding. That is the highest benefit to the humanity making use of data. For example, in the smart parking, you might just have data like this is full and this is empty. You collect the data that in this car park you have 100 empty space and 100 full space, altogether 200. But then if you process the data further, you might get information of who is parking in this lot, what kind of vehicle, where is this empty parking lot, and when is the peak period time. Let further process the information, you might find out that how to implement a tier charging, how to find overstayed vehicle. And further up, why my parking utilization is low. So you have to base on the knowledge and based on the information to answer the question how or why. And the wisdom based, it's not wisdom based will be evaluation of the why here. After you have come up with the why, you might want to further evaluate whether this solution, whether this answer is sensible, acceptable, or whether you have other solution on it. That will be based on your wisdom, and wisdom is based on your experience as well. This is an example of smart parking in which you might base on the analysis of your data, from data to your information to the knowledge to the understanding, and utilize it and implement your parking with sensor, location of parking availability, that you can check which lot is available at which level, particularly which location, then parking utilization and tiered pricing parking. Now, how could you implement the value of data in the case of smart waste? Spend some time to find out. 5 trends in the Internet of Things IoT job market in 2022. The first will be the IoT hardware. We need some people expert to maintain the hardware. Also the IoT software, IoT services, to find out what kind of services that can be applied or can be supplied, can be provided to the customer. And the cybersecurity again is a big issue because you are collecting data which involve privacy. IoT specialists learning IT skills, and also the those specialists that can provide trainings, they can provide the design, they can do the research, they can design the algorithm, and so on and so forth. So you can try to find out from this data nation. Challenges in designing IoT. The first, the creation of new interaction paradigm and new media convention that exploit the new machine sensing capabilities offered by technology and take care of human spontaneous way to discover the real world is a great challenge for today's designer. So how do you actually create the machine sensing that is capable to capture the human behavior or human spontaneous way to discover the real world or the real situation? The next would be the challenge of technology, the interactive technology in terms of the sensor that we are using or the actuator that we embed into the different devices. The next challenge will be the user acceptance. This is one of the main issues when we introduce a new technology or new service. There will be always an issue that we need to get people to understand and accept this technology, as we are collecting data every moment. So people might be worried about their own privacy. Early adopters are generally happier looking a bit strange or doing things somewhat awkwardly to reap the benefits of the new gadget. So we need this group of so-called pioneers to test out this new technology. Privacy. With the number of sensors being deployed, it isn't always clear whose data is being gathered and how we use the data, and is your data actually being shared to the third party? So this is again another privacy issue, another main concern, or another challenges in designing IoT. Like say for example, you have a camera deployed in an advertising holding which can check to see whether people are looking at different advertisements, right? Does the data belong to the company that installed the camera or to the members of the public who are looking at the advertisements? Let's take a look at 10 IoT design principles to consider. First, you must have a bird's eye view of IoT system that you want to design for the whole company, organization, or your platform, or your plantation of your agriculture. Work on branding. You will have to actually focus in one point that it's so very important in fulfilling your goal. So that will be your brand. Apply existing UI expertise to solution. This is not to reinvent the wheel. You can reuse whatever that is available in the market. Then consider human connection, whether you want to disclose this data to different parties and to what extent that they need this data, whether this data is needed at the information level or knowledge level. Effective data management design is also important. Then prioritizes security first, again, security, privacy. Focus on creating value. You don't just invest in a new technology without bringing any value to your organization. And work on delivering contextual experiences. So for example, if you are focusing in agriculture, so what kind of experiences that you want your employee to experience? So based on different contexts, you are going to deliver your IoT system. And lastly, do research on your target audience. What are the main ingredients for an IoT product? You will need to have sensor or actuators, that's for sure. And you will need a connection for the sensor connected to the cloud. The cloud will be the storage of your data most of the time, and also your application. We will be looking into cloud computing in the next module. What kind of services that you can get from there in order to realize your IoT system. Then you will need mobile or iPad device in order to check the information, to do analysis, to perform automation or control. Then you will need a powerful processor as well. And of course, everything must be connected. Following a new design process to outline the entire experience ecosystem, so you will need to also design on the services, the service that you are going to provide in terms of your IoT. Then interaction design, how do you interact with the devices? Because most of the time the device might be just a sensor, which you just collect data. The sensor just collect data. You cannot interact with it. So how are you going to interact with the data? That will be the interaction design. Interaction design will be designed at different levels. Say, for example, how the software engineer interact with the set of data will be totally different from the end user interacting with the data, because end user most of the time will be only looking at the information, not the raw data itself. But the software engineer or data analyst is going to interact with the raw data. Then the visual design, the user experience design, product design, and lastly the technical design. What kind of technology that you're going to involve? Are you going to use iPad only, or you just support smartphone, or you just support laptop? Now let's take a look at the differences between the user experience, or in short UX for IoT, and user experience for other digital services. IoT deals with devices that are distributed in the real world, the sensor, the actuator. Computing power and networking is embedded in objects and environment around us. So now computers are used in a wide variety of situations. We believe in a thorough understanding of the user's specific needs. So this is one of the different experience in the IoT, because IoT involves vast more scale coverage area of the system. The next is that user experiences involve digital and physical domains. The presence of multiple devices create more complexity for the user understanding. IoT products and services need clearness and simplicity. Because say for example, in an agriculture plantation, you might have over hundreds or over thousands of sensors installed. So how do you actually create or involve user? It must be, the services that you create must be clear and very simple to use. Interaction can happen in a wide variety of contexts, because we deal with a wider variation of the device types, especially for mobile devices with or without screens. Connected devices dramatically affect the user experience. Functionality can be distributed across multiple devices with different capabilities. Some devices might not have any input or output capability, because they just collect data, that's all. you cannot set or you cannot do something on the sensor. You can just actually pre-program it and they will be doing their work. So there is no so-called input keyboard or output keyboard, no. Interaction might be handled by web or smartphone apps automatically. Alright, IoT is all about data. Data is at the core of smart services. So big data can be user-centric, resulting in an improvement of user experiences. Network and embedded devices allow us to capture data from the world and use it to deliver better services to users. That's the difference from your simple mobile apps only. This one is about big data. Compared to a conventional digital service, there are more places where code can run. A typical IoT service is composed of one or more embedded services or devices, a cloud service, perhaps a gateway device, one or more control apps running on a different device, such as mobile, tablet, or desktop, and providing different services. And IoT is largely asynchronous. Maintaining connection uses a lot of power. IoT design has to deal with discontinuities in the user experiences. As a result, parts of the ecosystem can be out of synchronization. So sometimes it cannot be synchronized. You must design this kind of experience to allow asynchronous processing. It can be a batch processing, batch by batch processing. What is the emerging design model for IoT? So from the platform design, least visible to most visible, for the end user, the UI or the visual design, this part, the screen layout, look and feel will be more visible. As you go down, this will be less visible, like conceptual model. How should user think about the system, the service design, productization? All this will be not so visible, but as you go up, like interaction with the end user, it will be more visible. The design model will be more visible. So for example, interusability, interaction spanning multiple devices with different capabilities. So how do you actually deal with these different devices? Industrial design, physical hardware that you have to use for different industry. Interaction design with the device, with the service. And end of the day, the most visible part to the end user will be the UI design. For interface and interaction design, different types of interaction. You can have actually different device, different sensor, you will have different kinds of interaction. And sometimes one device might only involve one kind of interaction. Like for example, that device might only be able to capture the seeing. So they receive output through seeing, like CCTV, used in LED screens only, but not the sound, not the smell, not the voice, not the temperature sensing. Some, like for example, some sensor only sense the temperature, but very specific. So you will have to go through each of these: input, receive, output through, use in which device, which interface, then design your IoT. Interusability isn't a separate set of design activity, it's an extra set of consideration to be addressed in tandem with interaction and UI design. The key differences to a single device user experiences design process would typically be specifying which function belong on each device, and then creating design guidelines that span multiple device types, then designing cross-device user flow for key interaction, design multiple device UI in parallel, working in parallel because you have many devices. So the conceptual model, in terms of the conceptual models, for example, home automation routines stored in a cloud will not run if the internet connection goes down. This is cloud-based, yeah? And then cloud-based, definitely you have to connect to the internet. If they are stored locally at home, they will continue to run, but the user won't be able to see this or control device remotely because you are not connected to the internet. So in short, or in summary, if you want to have a real-time connect to your device, you must go through cloud computing and the internet connectivity. Responsible in IoT design, Why IoT security is a big challenge? Because now everything is connected. For example, the smart connected fridge that will know when I've run out of milk, automatically place order. This seems like very beneficial to your house. But when that fridge also has access to your credit card because they place the order automatically, and then can wirelessly unlock a door for a delivery person, it becomes less beneficial, and it will create worry, especially if it depends on the security model design for a fridge that only plugs into a power outlet. So what if it is unplugged? There is no power supply. What will happen? Does it actually allow the delivery man to come in freely? So this is one of the security issue or concern that always found in this IoT design. So basically, that's all for the IoT, the technology, the component, the designs, the responsibility, the concern, especially the security and privacy. Until then, I will see you in the next video clip.